Well, let's start by defining what a linear equation is. First of all, an equation is a mathematical statement that tells you that two expressions are equal. So, for example, we've got two equations there. We've got 2x plus 3 is equal to 4x minus 7. Now, this statement here asserts that that expression, 2x plus 3, is equal to 4x minus 7. That's what an equation is. Now, the second one is also an equation. We have x squared plus 8x. This is one expression. And the second expression is 2x plus 9. So this equation is telling us that these two expressions have the same value. They are equal. All right. Now, one thing that we should know about equations is that they always have one or more variables. Now, this particular equation here, the first one, has one variable, which is x, okay? And the numbers that are not variables are called constants. So 3 and 7 and 7, or minus 7 in this case, are constants. Now, we've got here 2x. So the variable is x. 2x is a term in x, and the 2 is called a coefficient. So when you have 2x, x is the variable and 2 is called the coefficient. So in this expression here, 4x minus 7, the coefficient of x is 4 there, right? And over here, the coefficient of x is 2. Over there, the coefficient of x is 8, right? But x is the variable in both cases. All right. Okay. Now, solving an equation means finding the value of the variable, which is often called x, but not always. I mean, we can have equations in other variables. It doesn't have to be x, but oftentimes when an equation is given, you'll see x there as a variable. Now, when the highest power of the variable is 1, then the equation is said to be linear, because we're talking about here solving linear equations. So we need to understand what a linear equation is. A linear equation is an equation whose variable has the 1 has its highest power. So you're not going to find any power of x that is higher than 1. Okay, so if you look at the first of our examples, 2x plus 3 is equal to 4x minus 7, we see there that all of the terms in x have a power of 1. I mean, x has the power of 1, right? So if you consider, for example, if you consider 2x, the power of x here is 1, because x to the power of 1 is just x, right? So that's what we mean by having a power of x not higher than 1. Now, the second example, we've got 3 terms in x. Rather, we've got 2 terms in x and 1 term in x squared. Now, x is the variable in this equation, but we've got 1 term that has a power that is greater than 1, which is the term in x squared. So this equation is not linear. Okay? All right. Now, so we've defined what a linear equation is. Now, here's our first example. X plus 2 equals 15. We need to solve for x. The variable here is x. We want to find the value of x. Okay, well, let's do that. When we try to solve a linear equation, the objective is to isolate x in order to find its value. And you'll notice that an equation has two sides. You've got the left-hand side and the right-hand side. Okay, so what we try to do is to take all the terms in x, because we're trying to solve for x. So we look for the terms in x, we put them on one side, and all the other terms, we move them to the other side, because we want to isolate x in order to determine its value. That's what we're trying to do. So in this case, we've got x plus 2 is equal to 15. How do we isolate x? Well, we can isolate x by moving 2 to the right-hand side. But how do we do that? Well, because it's an equation, whatever we do on the left-hand side, we must do on the right-hand side. So if I want to isolate x by moving 2 to the right-hand side, I need to subtract 2 from the left-hand side. But if I do that, I will also need to do it on the right-hand side. So here, I'll now have x plus 2 minus 2. Then I'll do the same on the other side, 15 minus 2, right? So I've taken away 2 from the left-hand side, and I also take away 2 from the right-hand side. So that causes me effectively to move 2 to the other side. So we can see that 2 becomes minus 2 on the other side. So I haven't really moved it per se. What I've done, I've subtracted the same amount on both sides because I want to isolate x. Right? So it looks as if I've moved it. I mean, it's a good way of looking at it, right? It's 2 on the left-hand side. I move it to the right-hand side, and I end up with minus 2, right? It changes signs. So that's it. That's what I've done. But what I've shown you here is the mechanism that we're actually using in the background to isolate x. Okay, I'm just not moving 2 for the sake of moving it. I'm actually subtracting 2 on both sides. That's what I'm doing. All right, so 2 is gone to the other side. It's now minus 2. So x is now equal to 15 minus 2, which is 13. Right? That is the solution of that equation. X is equal to 13. Example number 2. Now we have x minus 4 is equal to 15. We need to solve for x. X is the variable. We want to find the value of x. Okay, so we'll do the same thing. The aim, again, is to isolate x. We isolate the term in x. And in order to do that, we want to take this minus 4 and move it to the other side. By moving minus 4 to the other side, it becomes plus 4, right? But what I'm actually doing, I just want to explain that so we understand what is happening. What I'm actually doing is add 4. I'm actually adding 4 because here we've got x minus 4. If I want to get rid of this minus 4, I've got to add 4. That's how I cancel it out. But if I add 4 to the left-hand side, I need to add 4 to the right-hand side. Okay, so now I end up with x is equal to 15 plus 4. That's actually what's happening. All right, so minus 4 moved to the right-hand side becomes plus 4. So now we have 15 plus 4, which is 19. So the value of x is 19. That is the solution to our equation. Example number 3. Three x is equal to 15. Now, again, I've been asked to solve for x, so I want to find the value of x. Now, how do I do this? This time, I've only got one term in x, which is 3x. So x has a coefficient, which is 3. Now, I can't just move it to the other side, because if I can't move 3 on its own with the other to the other side like I did before, because 3 is a coefficient, right? But I still want to get rid of it because I want x to be on its own. How do I get rid of this 3? Well, the way to do it is to divide 3x by 3, right? So if I divide 3x by 3, then I'll end up with x on its own. So because we know that 3x divided by 3, these 3's cancel out, and I'll end up with x on its own, right? We know that. So here, that's what I'm going to do because I want to isolate x. I'll divide 3x by 3. But if I divide the left-hand side by 3, sorry, not 5, 3, by 3, then I must also divide the right-hand side by 3. So I end up with x is equal to 15 over 3, right? Well, 15 over 3, of course, is 5. So x is equal to 5. That is the solution of our equation. X is equal to 5. Example number 4. Now this time we're not solving for x, we're solving for a. So this equation has a as its variable. I told you that sometimes the variable of an equation is x, but it's not always the case. In this particular equation, the variable is actually a. So let's solve for a. Again, we want to take all the terms in a, go to one side, and everything else goes to the other side because we want to isolate a. So we start by moving all the terms in a to one side. All right. Okay, how about we move it to the left-hand side? So this is the left-hand side, and this is the right-hand side. So we've already got 5a on the left-hand side. Let's take 2a to the left-hand side as well. All right. So we end up with 5a. 2a moved to the left-hand side becomes minus 2a. And of course, 4 moved to the right-hand side becomes minus 4. So 10 is still here. So we don't touch 10. 10 stays there. But 4 moved to this side becomes minus 4. Okay? All right. So now 5a minus 2a is 3a. 10 minus 4 is 6. Okay, now we've got 3a is equal to 6. But I need to solve for a. And the way to isolate a is to divide both sides by 3. So I need to divide 3a by 3. But if I do that, then I must also divide the other side by 3. All right, so now these 3's cancel out. So I've got a here, and then 6 over 3 is just 2. So the solution to this equation is a equals 2. Example number 5. Now we are asked to solve for t. The variable in this particular equation is t. All right, let's go ahead and solve that. Again, we want to isolate t, which means that the first thing we want to do is to take all the variables in t to one side and everything else to the other side. All right, so 7t is already on the left-hand side. So we take 4t, we move it to the left-hand side, and then minus 3 goes to the right-hand side because to separate these variables. All right, let's go ahead and do that. So now we've got 7t. 7t is still there. We take 4t, we move it. It's now minus 4t. Okay. All right. Minus 3 is moved to the right-hand side and becomes 3. And minus 5 is still there. Okay. Now, 7t minus 4t is 3t. 3 minus 5 is minus 2. And t, of course, in order to isolate t, we divide both sides by 3. T is equal to minus 2/3. That is the solution to that equation. Example number 6. Solve for x. We're back to x again. Okay, now we've got x over 4 minus 8 is equal to 3x minus 2. Okay, this is a little bit different from what we've been doing. Here we've got a fraction. One of the first things we want to do when we have a fraction in an equation is to get rid of the fraction. It just makes life so much easier not to have a fraction when solving an equation. So because the denominator of that fraction is 4, what we want to do is to multiply all the terms of the equation by 4. I mean, we multiply absolutely all the terms by 4. How many terms we have? We've got 4 terms. We've got x over 4, we've got minus 8, we've got 3x, we've got minus 2. So these are the 4 terms that we have in this equation. All right, so every single one of these terms will need to be multiplied by 4 in order to get rid of this. All right, remember, when we do something to one side, we've got to do it to the other side. All right, so what we're doing is this. We're multiplying this by 4. We're multiplying this by 4, right, which is 32. I'll just write it down there. We multiply this by 4, which is 12x now. And we multiply this by 4, which is minus 8. Okay, and of course, by multiplying x over 4 by 4, these 4's cancel out. So you now end up with this equation here: x minus 32 is equal to 12x minus 8. Okay, so this is a bit more manageable. Now we can do what we did before. We'll take all the terms in x to one side and everything else to the other side, right? So now, what I can do, I've got x here. I could move 12x to this side, but what I'm going to do, I'm actually going to take x and move it to the other side. You can do it either way. The reason why I want to do that is because when I move x to this side, I'll end up with 12x minus x, right? Which gives me 11x. But if I move 12x to that side, I'm going to end up with x minus 12x, which is minus 11x. I mean, it's not a problem. I can do it either way, but it's just a matter of convenience. I don't want to mess around with changing signs and all the rest of it. So what I'm going to do, I'm just going to move x to the other side, and I'll move minus 8 to that side there. It strictly speaking, it doesn't matter. It doesn't matter how you do it. In fact, I'm going to do it both ways to show you that it really doesn't matter at all. So let me start by doing it the way we did it before, by moving all the terms in x to the left-hand side, and then everything else to the right-hand side. Let's start that way, and then I will show you the other way. Okay, so x stays here. 12x moves to the left-hand side and becomes minus 12x. Minus 32 moves to the right-hand side and becomes 32. And minus 8 is still there. Okay, so now x minus 12x is just minus 11x. 32 minus 8, that's just 24. Okay, so I'm just going to continue up here. Now, in order to isolate x, I've got to divide both sides by minus 11. If I divide this side by minus 11, I end up with x. And I divide that side by minus 11, I end up with minus 24 over 11. That is the solution, minus 24 over 11. Okay, now let's do it the other way. We'll get the same answer. Again, we multiply every term by 4 to get rid of this fraction. So this gives me x here times 4, 32. 3x times 4 is 12x. Minus 2 times 4 is minus 8. Now, I move x to the right-hand side, and I'll move minus 8 to the left-hand side. Okay, so now this gives me minus 32 plus 8 is equal to 12x minus x. Minus 32 plus 8 is minus 24. 12x minus x is 11x. Okay, so now to get x, I'll just divide both sides by 11. If I divide minus 24 by 11, I get minus 24 over 11, and 11x divided by 11 is just x. There you go. And then, of course, it's a little bit unusual to write it like this, so I'll just rewrite the solution by putting x on the other side, flipping it basically. X is equal to minus 24 over 11. That's it. It's effectively the same thing. It's just a matter of convenience which way you do it. It really doesn't matter whether you move x to the right-hand side or the left-hand side. It's just a matter of preference, how you want to do it, and a matter of convenience. That is a solution to this equation. example 7. Okay, again, we have a situation with fractions here, but this time we've got two denominators involved. We've got 5 on one side and 2 on the other side. So what we want to do is multiply both sides. So there's a bit of a typo here. Okay, typo corrected. Right, so we've got two fractions with two different denominators. One has denominator 5, the other one has denominator 2. So the thing to do here is to multiply both sides by a common multiple of the denominators. Ideally, the lowest common multiple. It doesn't have to be the lowest, but it's easier if it's the lowest common multiple of the denominators, right? So the lowest common multiple of 5 and 2 is 10. So the easiest thing to do here is to multiply both sides by 10 in order to get rid of the fractions. All right, so let's go ahead and do that. Then we'll start solving our equation. So 3x minus 4 over 5. I'm going to multiply that lot by 10. And I'm also going to multiply this lot by 10. Right? Which means that I'll multiply this by 10. And I'll multiply that by 10, which is 30. Right? The reason why I've multiplied this this by 10, this lot here by 10, is because this is one term. Right? This whole thing is considered as one term. These are two separate terms, but this is a single term. So I've got to multiply this lot together. Okay, so doing that, what's going to happen here is 10 will simplify with this 5. So what I'm actually doing, I'm dividing both. I'm dividing 10 by 5, and I'm dividing 5 by 5, which gives me 1 here, and that gives me 2 here. And I'm dividing this by 2, and dividing that by 2 gives me 1 here, gives me 5 here. Okay, I'm simplifying that. So now I end up with 2 times 3x minus 4 is equal to 5x minus 30. Okay, then I can expand the brackets here. 2 times 3x minus 4 is 6x minus 8, and then equals 5x minus 30. Okay, so now we've got something that we can really work with, right? All the terms in x can go to one side, and everything else goes to the other side. So 5x goes to this side. That gives me 6x minus 5x. Okay, and then minus 8 goes to the other side and becomes 8. So now we've got 8 minus 30. All right, so I'll move my calculations here where there's a bit more space. 6x minus 5x is x. So I've successfully isolated x. 8 minus 30 is minus 22. And that is the answer. That is the solution to my equation. All right, example 8. Same routine. All the terms in X go to one side and everything else goes to the other side because we're solving for X. So I've got minus 5X here. 2X goes to the other side and becomes minus 2X. 7 stays. Let me just clean this up a little bit to make that X look like a proper X. Okay, 7 stays. 4 goes to the right-hand side and becomes minus 4. So minus 5X minus 2X is minus 7X. 7 minus 4 is 3. I want to isolate X, which means that I have to divide both sides by minus 7. So if I divide this by minus 7, I end up with X. And I divide this by minus 7, I end up with minus 3 over 7, which is the solution to my equation. X is equal to minus 3 over 7. Example number 9. Again, we solve for X. Now, if you notice, this equation does have some numbers. It has X as a variable, but there also seems to be another variable there, which is A. But A is not the unknown variable. So we're not solving for A, we're solving for X. So we're going to behave as if A is a constant. Right? We're going to behave as if it's we're fixing A. So we're not going to behave as if it's something that we want to we're trying to find the value of. All right, so that's not what we're doing. So we're solving for X. Okay, let's go ahead and do that. We do exactly the same thing as before. All the terms in X go to one side and everything else goes to the other side. So I've got 7X on this side. X goes to the left-hand side and becomes minus X. 8A stays in the right-hand side. Then I move 2A to the right-hand side and becomes minus 2A. Okay, now 7X minus X is 6X. 8A minus 2A is 6A. I want to isolate X. So I divide this side by 6, which means that I must also divide the other side by 6. So I've got to divide both sides by 6 because I want to isolate X here. All right, doing that, I'll end up with X is equal to A. That is the solution to this equation. Example 10. Similar to the previous example where we had numbers, but also another variable there, which is A, but we're not solving for A, we're solving for X. So we will not treat A as a variable per se. But the difference here is that A is actually a denominator. Now, remember what we said before, when you're dealing with a fraction, the first thing you want to do is to get rid of that fraction. And that's exactly what we're going to do here. In order to get rid of A as a denominator, we've got to multiply all the terms by A. So we multiply this side by A, so we end up with A So I'll put a times 4x divided by a, okay, like so. 3x times a is 3ax. Minus 1 times a is just minus a. Okay, so these two a's will cancel out, giving me 4x, right? So I got rid of the fraction now. Now 3a x minus a. Now remember, all the terms in x need to go to one side. Okay, so I've already got one term in x here, which is 4x. The other term in x is 3ax. That term needs to go to the other side as well because I want to isolate x. So now we've got 4x minus 3ax. See, 3ax moving to the other side becomes minus 3ax, and then minus a stays there on its own. Okay, now how do we isolate x here? Because we're not dealing with numbers. So if I had something like 4x minus 3x, that's easy. 4x minus 3x is just x, all right? So 4 apples minus 3 apples is just 1 apple, right? So that's easy. But then how do I do it when I have 3x minus 3ax? So I can't do the same thing, right? I can't do the same thing because I don't know the value of a. I don't know what a is. So I need to come up with a way of isolating x so that I can solve that equation. Well, the way we do that is by factorizing. So we factorize this expression in such a way that x is becomes a factor. So 4x minus 3ax can be written like this by taking x out into out of the bracket. So x times 4 minus 3a. You'll find that once you've expanded the bracket, you'll get back to 4x minus 3x, right? So that's how we factorize it. X comes outside of the bracket, so we are assuming that there are brackets here, right? We're assuming that there are brackets there. So x goes outside of the brackets. You end up with 4 minus 3a is equal to minus a. Okay, now it's easy to isolate x because all we need to do now is to divide both sides by 4 minus 3a. Okay, so if I do that, so x times 4 minus 3a divided by 4 minus 3a is equal to minus a divided by 4 minus 3a. Remember, if I do something to one side, I've got to do the same to the other side, right? So 4 minus 3 and 4 minus 3a, these cancel out. Yeah, because this is a multiplication. I haven't written it because we've got brackets there. But these two will cancel out, leaving x on its own. And the solution is x is equal to minus a over 4 minus 3a. That is a solution to our equation. Okay, so that brings us to the end of our video. So we've solved 10 different equations to show the various techniques that can be used to solve linear equations. Go over the video, and before the solution to a worked example, pause the video, work out the solution to the example yourself, and then watch the solution as a way of practicing. So watch it over and over again until you've mastered it, okay? And that's all for today, and see you at the next lesson.